In the 1960s, John Bell, a physicist from Northern Ireland, moved things on by turning the EPR experiment into something that could be practically tested. This was finally done over a tiny distance by a French team led by Alain Aspect in the early 1980s. In 1997, a team in Geneva attempted the experiment on a much larger scale. They tried to demonstrate that a pair of quantum particles actually do have a strange, spooky connection, this time across a whole city. If Nicolas Guizin and his team were right, then they would have proved one of the greatest scientists of all time was wrong.
Well, it's a long, long journey, of course, and it goes back to Einstein and even before. I mean, Newton, you can go back. And it's also certainly not the end of the journey. So if we go back to, let's say, Einstein at this time and Einstein-Bohr debate, at that time they had to swallow the revolution of quantum mechanics and to accept the new physics and the new views. And indeed, the paradoxes, like the EPR paradoxes. And well, my part of the journey probably was to test that, to understand it, to test it, and to participate to this new way of looking at quantum mechanics as a resource to produce new things, cryptography, computing, and so on. And with my team at Geneva University, we had a chance to test experimentally the issue. And I hope I will continue that journey.
For this experiment, they had to create a pair of quantum particles. They used photons, which are particles of light. Like gloves, one photon must be opposite to the other. The key was to separate them by 10 kilometers and then measure them at exactly the same moment. There would be no time for a message to pass between the photons.
So this is where the experiment started. We created our photon pairs and then sent them to the other stations where they are measured. It starts at a red laser, which you see here. Just see the reflex on my finger. And this laser light is then focused into a nonlinear crystal, which you find here. And this is actually the heart of our experiment.
The idea is to have two photons which are produced at the same time. In principle, you take one photon, and in a nonlinear crystal, you let it divide into two twin photons. There are two photons, but they together form one system, one quantum system.
One of the photons is then coming out by this fiber, going through the fiber network, which you usually use for phone calls, going all the way down to Bernay in this direction. The other photon is coming out here, again in the fiber network, going all the way to the other side, to Bellevue, where we make the other measurement.
Going to telecom fibers gives us a possibility to go over long distances, because these fibers are very well tuned for that. One village is near the Lake of Geneva, and is about 5 kilometers north, and the other one is about 5 kilometers south. And so we have this 10-kilometer direct spatial separation. So if then on the north of Geneva, let's say on one side, we do a measurement, then the photon on that side acquires a property, and instantaneously in theory, and certainly faster than light in practice, the other one there also gets the opposite property. The output on one side is random, completely random. The outcome on the other side is also completely random. However, the two outcomes are always opposite. Not only do we not know which photon has which property, but according to the theory, well confirmed by the experiment, the photons themselves don't know. So in some sense, nature itself doesn't know. And we find that on this very rare occasion, Einstein was wrong.
So nature really is weird. Until someone makes a measurement, two photons can exist in a tangled up state, both being and not being at the same time. This entangled pair of photons are somehow connected across vast distances.
And the property still holds. Probably, according to quantum mechanics, if you go to the moon, it's still there. It's more difficult to test, but it's quite a fascinating prediction.
Einstein nil, Bohr 1.
Poor Einstein, I'm sure he'd be very upset if he saw the results of the aspect experiment and these others that have been done, because it would force him to make a choice between his beloved theory of relativity that forbids faster than light signaling, or his implacable opposition to the idea that nature is fundamentally indeterministic. It's fascinating to wonder which side he would come down on.